Okay, so good evening everyone. If you're able to hear my voice, kindly say yes into the chat. Just let me know if you're able to hear my voice loud and clear. Very good evening. Good evening, ma'am. So my voice is clear? Okay, thank you. Very good evening, everyone. Okay, so let's get started with the today's session. Okay, great. So as we already discussed into our previous session, like after we have done with the basic understanding of a site layout planning, today we will be going for the much more detailed case study. Okay, but before moving to completely a new type of a case study, let's have a quick glimpse of what are the things or what are the elements we need to keep in our mind while doing the site layout planning into the site. Very good evening, George. So we have already seen the terms. Whenever I need to do the site layout into the site, right? So I need to take care of the safety prospect. That is the most important element, right? Whenever I'm going to keep any of the temporary facilities or the layout planning, it should be safe enough, right? It should provide, definitely that is going to increase the morale of my labors also. Site accessibility should be there. Yes, it should be accessible to all part, right? Like we have seen into the previous case study, there are some elements, the case study which we have seen last time. I hope everyone remember, right? So as we are able to see, the timber yard is very difficult to reach, right? Reinforcement stock pile is very difficult to reach. So the metal will be unloaded near to the road. So again, it need to be shifted by the labor to that particular stock pile. So it is very scattered. So it should not be there, definitely. Then information signs, wherever it required, there should be appropriate information signs like one way, two way, heavy vehicles not allowed. It's all site sign kind of, even that site map should be there, because when we talk about a greenfield project, so in that project, the pathways or the roads or the new elements or new structures are raising. So every, after a couple of months or a quarter of months, the layout is changing very drastically. Okay, so everyone should be aware. Even the emergency routes should be clearly marked out. Security, definitely security plays a very important role. If needed, accommodation. So last session we already seen what is the thumb rule for the accommodation. Anyone remember? Like what is the norms for accommodation? In which scenario I need to provide the accommodation into my site? Anyone able to remember it? I will just run a poll. Very good evening. Okay, so accommodation need to be provided, or as per the thumb rule, there is no standards are there. But if in the case 95% or more than of the labor are coming from particular distance, so that time it becomes compulsion for me to provide the accommodation into the site. So that is a 30 kilometer, 50 kilometer, or the 60 kilometer. We have already seen into the last slide. Very good evening, everyone. Okay, good enough, good enough. So 50% of your saying no. Okay, 50% of your saying 30 kilometer and 50% of your saying 60 kilometer. Okay, so the whole group is divided into two parts. Very good evening, dear. Okay, fine. So 57% are right now stating to 30 kilometer and only 43% are stating for 60 kilometer. Okay, but the right answer is if the distance is more than 60 kilometer. right? Then only you need to be providing the accommodation into the site. Okay, so we have already seen into our previous session. Similarly, if needed, we need to provide the site office or the client office, that is as per the need. Definitely the most important point, you're going to spend around 12 to 15 hours minimum into the site, right? So you require a water supply and sanitation, because many of the sites are going to work for 24 hours. Very good evening, Dheeraj. Similar way, material handling, okay, and the storage and the site cleaning need to be taken care of. So whatever the temporary facilities we require, it may be in the terms of batching plant, cutting bending yard, so that things need to be provided, and location of the facility. So in that we have learned a very important term, that is the principle of minimum movement. So what is that principle of minimum movement? Means whenever I need to stack the material or the store the material or going to put it into the layout format, so no need to move that material again and again, right? If I need to explain with a example, just take a case of, if I'm having a tower, right, and at the center of the tower I am having a crane, tower crane I am having. If I'm going to unload the material somewhere away from that range of the crane, so first I'm going to unload it, then once I have need to put the labors to unload the element, right? After unloading, because it is can't be taken in the radius of the lifting of the elements, again that need to be moved near to the crane, again from the crane it need to be moved. So there are unnecessary many principal movement we are doing. So I need to try it around, how I can make it a minimum number of principal movement, right? Sometimes we need to do it, maybe because of less area availability or some kind of a different complexity, that time we may need to do, but we need to try to avoid as a minimum movement need to be there, so that my productivity is not going to get lost. So this we have already seen. Now I hope everyone has joined also. Fantastic. So now we have already done this case study, so I'm not going to spend a time on that. I hope everyone remember that element. So today we are going to do a very fresh case study. So we have already seen, we have already learned this element. Okay. So now let's move to a new particular. Okay. So in today's session, what we are going to do, we are going to just have a glimpse of the current practices into the site in the terms of the site layout, like how exactly I do the planning of the construction site layout. Then we will directly switch to a case study part, right? So when we are doing a case study partner, so what I will do first, I will try to make you solve a very small case, so that you're going to have a hands-on, and then we will move to the bigger case part. Okay, now let's get started. Okay, so site layout, basically I can say in a very smooth word, or in a very simple terms, I can say, to make my work flow very smoothly into the site. That is basically the site layout planning. That is the main intention of doing the site layout planning, right? The better I am going to do the site layout, the better the flow of my elements is going to take into my site, right? So there are various construction resources like material, men, machinery should be arranged in such a manner that optimal utilization of the space should be there. Even last time we have seen the heuristic approach and the optimum approach, right? That we have seen how to take a decision. Now, a sort drawing of, like I can say, the layout drawing or the site drawing of the proposed construction showing the temporary facilities, right? Why we are saying it is a temporary facilities? Because that facilities are not going to be seen when the construction is over. You're never going to see the cutting bending yard, quality lab, batching plant setup, material stacking setup after the clients are getting position. You're not going to see it, right? That's why it is called as a temporary facilities. Nowadays we already discussed, right? In current practices, generally we give the responsibility to any one particular person, and he's use his own experience and previous site experience, and he do the site layout planning. Definitely that is a very good approach, but we already learn, after doing that, just discuss with your team members, so that everyone will be on the same page, where exactly we are proposing, what are the different elements, so that if any kind of a suggestions are there, even the inter-department, that also can be taken care of. Okay, and good site layout planning definitely leads to a uniform flow of the material, right? Control on material and the equipment theft, right? Facilitate the equipment smoothly, no need to wait the vehicle for a longer time. Promote a safe working environment, right? Non-destructive access to the job site visitors or also can be a feature of the same. Yes. Now last time even we have seen the temporary facilities sizing. Last time we have seen this, how to calculate the sizing of temporary facilities. No, no, last time we have not seen it. Yes. Okay, now let's see. This is a very important part and the critical part of our temporary facilities, right? Now just you need to understand it in a very nutshell way. I will going to tell you, right? Just wait. See, if I'm going to talk in a very broad way, which is going to give you a very better clarity, whenever I need to do a site layout planning and the management, right, the whole thing can be divided into three particular parts. The first part is identification of the temporary facilities, right? So first I need to identify the facilities. Okay, like identifying facility means, for example, if we have done a contract with the client, okay, now I got some of the basic drawings or the layout drawings of the project. I have gone through some of the contract tender document of the same, right? So a person is getting a rough idea of the project. They are getting a scale, magnitude, complexity, site scenarios, right? Local conditions. So they are getting the basic insights about the project. Now, on the basis of that, can I decide what are the temporary facilities are going to require into my project? Definitely, I can able to decide it. Right? Yes, there may be some kind of a temporary facilities. Maybe like I may forget in the start, but I can add on as my project is moving. So first and the most important part is identification of the temporary facilities. So you can do that element. Once you are going to know about your project, you're able to do the identification of the temporary facilities. So that is not a big issue. We are going to do the case study, don't worry. But that is the element which you are able to solve it, right? Now the next part is, once you have identified it, what are the temporary facilities you're going to require into your site, the next critical part is sizing the facilities. You should be able to decide how much should be the size of the temporary facilities. That we will try to see into the formula, and then we will move to the placing them or linking them to each other. Okay, so how to do the sizing of the same, that we are going to learn from this particular formula, right? So let's try to focus on the formula. When I need to calculate the area of temporary facilities, right? Now I need to calculate the area of the temporary facilities. So how I am going to calculate? So area required equals to Q max slash IM, right? So what is the Q max? Q max is the maximum estimated quantity. Like, what is the maximum quantity? For example, if I need to calculate how much cement, like I need to keep a cement storage, right? So what is the maximum quantity of the cement bags I'm going to require in any particular month, right? That I'm going to calculate. What is the maximum estimated quantity I need to keep into that storage yard? So that is the Q max. Okay, divided by IM. What is the IM? It is a utilization index of the material. So that we are going to get from the table here. See the second last column. Able to see the second last column, right? So in that we are going to get the utilization factor. Utilization factor means how much that going to take a area of. Okay. Okay. So there is a question from Dheeraj. Sir, it is necessary to submit safety plan and procedure to start the project. See, yes, whenever the client demand or client required, like before starting of any of the new site or a new like work order, or you're starting with some of the element which is not till now done into your site. So any new thing is going to start, you need to submit the safety plan and procedure to start the procedure. Means if you're having like SOP, standard operation procedure is there, you need to submit that. What is the actual sequence you're going to follow, right? And you also need to take care of the safety plan for the same, right? That we need to submit it. That is making sure that even you need to take a sign of the client into that, so that they're also liable that these are the things we have taken care. If you have any kind of a suggestion, suggest us, so that increase the morality support to each other. Okay, so that IM factor I'm going to get it from here. So Q max I need to calculate, right? IM I am going to get from the table. Okay, then again the whole bracket divided by Qn. What is that Qn? Quantity of the material can be stored per meter square. So how many quantity of the metal I'm going to store into the per meter square? So that is also I'm going to get from the table. See the third last column from the back side, Qn. So for every metal I'm going to have a different quantity. From the formula I'm able to understand, only thing I need to calculate is the Q max. IM I'm going to get from the table, Qn I am going to get from the table. Sorted. So how to calculate the Q max? So Q max is the maximum estimated quantity. How much maximum quantity I can store into the storage space. So that will be equal to Q daily. Q daily means estimated quantity required per day. For example, averagely, if your project is of 2 years, so averagely you require like around, just a case of 10 cement bags example. So 10 cement bag I need to keep in a daily basis minimum. I need to have that into limit. So that is a Q daily requirement. Multiply by small t, that is the average stock. How much average stock you need to take care of. So how you're going to get it? You're going to get it from this table. See the fourth column from the front. Average stocks into the days. Right? So cement, the average stock should be like for next 30 days I need to be taken care of. Aggregate, similarly bricks, like concrete blocks, so I can take care of. So I can calculate the small t, multiply by the k. K is the fluctuation factor, which is also known as the wastage percentage. So how much metal I'm, because this is the requirement, and so how much is the wastage I'm like wastage factor I need to consider, because the extra quantity I need to take care of, that is the k. So k is the wastage percentage. See the last column of the table. So from where I'm also going to get the wastage percentage. Sorted. So I am able to calculate the Q max. So Q max is equals to Q daily. Q daily is the daily quantity required, multiply by T, average stock per day, multiply by K, that is the wastage percentage. So I am able to calculate the Q max. But the thing is that, so T and K you are going to get from the table. But from where you are going to get the Q daily? Okay, so what is the Q daily? Q daily is the estimated quantity required per day. So you are going to calculate by Q total, means total quantity of the material required for the project divided by construction period of that particular activity. Just take a case of, if I'm talking about a brickwork. Okay, so total quantity of the metal, for example, it required 2 lakhs of the bricks. Okay? And the brickwork, I'm not talking about a total duration of the project, I'm talking about a brickwork duration. So brickwork is going to take around 6 months. So 2 lakhs bricks divided by 6 months. So how many bricks you're going to require on a daily basis, right? That you're going to get it into Q daily. So Q total divided by T. So now see the reverse way. First I'm going to calculate the Q daily. How I am able to calculate total quantity required for the project divided by duration of that activity. As soon as I calculate the Q daily, I can able to calculate the Q max. So Q daily is calculated, multiply by small t, that is the average stock I'm going to get from the table, even multiply with the fluctuation factor, that is the wastage percentage I'm going to get from the table. So I calculate the Q max, just put into the area main formula. So Q max IM you're going to get from the table, that is the utilization index, and even the QN, that is the quantity of the material can be stored per meter square. So everything I'm going to get from this particular table, right? Okay, so let's see a small formula. If you are not getting it, I'm going to repeat it the once again, no problem. But like should I repeat the formula one more time? Are you able to understand it? Just let me know. You're getting it? No issues? Okay, fine. Okay, repeat. Okay, fine. Fine. I will repeat one more time. No issue. Now try to understand. In this particular step, I'm calculating the area required for my temporary facilities. Right? How much is the area I should be providing? Let it be for a stocking of the cement, stocking for the bricks or the rebars, right? How much area I need to provide it? There should be some logic, there should be some science behind that, right? So that we are going to derive from this particular formula. So how I am able to calculate? First, I need to take care of, I need to go reverse way. Actually, the main formula is area required equals to Q max upon IM, the whole bracket divided by QN. That is the main formula. Right now, I don't concern about that. I need to go in a reverse way. First, I'm going to calculate the small q daily. What is a q daily? Q daily is the estimated quantity required per day. First, I need to calculate the how much is the estimated quantity, how much approximate quantity you're going to require per day of that particular material. Right? So how you're going to calculate it? Q total, that is the total quantity of the material required for the project, divided by construction period. Right? Just take an example of just take a case of cement. Right? For example, for total construction, total quantity of the cement I required is approximately 900 bags. Just like example, or 1000 bags. Right? What is the duration I'm going to require for 1 year? So how many kgs or how many bags I'm going to require for per day, that I am able to calculate. Getting, so that is the Q daily quantity. Okay, anyone else is facing the same issue of not able to hear my voice or not able to see it? Audible. Okay, I think also just refresh from your side. Okay, fine. Now once I have done the Q daily, now I need to calculate the Q max. So Q max is maximum estimated quantity in a storage space. So how much the maximum quantity you are going to space any particular month? So that is equals to Q daily, which I already calculated, multiply by T small t. What is the small t? Average stock. How much is the average stock you can keep for that particular material? So how you're going to get it? You're going to get it from this table. See the fourth column from the front. Fourth column after the besides the unit. So average stock, no? So from here I'm going to get that small t value. Small t. And the k is the fluctuation factor. Fluctuation factor means how much wastage is allowed. So that is I'm going to get it. See the last column. Waste percentage. So here I'm going to get the waste percentage for different materials. So that I can put it here and I can calculate the Q max. That is the maximum estimated correct quantity in the storage space. Once I calculate the Q max, just I need to put into this formula. So I'm putting into the formula Q max. Then IM is already calculated. Material storage area. So you're talking about Q total. Okay. So Q total is the total quantity of the metal required for the project, right? For example, right, these are formulas are for the materials, right? So for example, if you talk about a cement, so cement will be taken care by the RCC. So how much RCC's duration is there? If you talk about a brickwork, so how many brick masonry is required? Right? If we talk about a sand storage yard, so how much is the again the RCC work? So that depend upon not the total construction of the project, but the activity completion or activity duration into the project. Okay, fine. So once I calculated the Q max, right, I just need to put it into my main formula. So area required equals to Q max divided by IM. IM is again here we have seen, see the second last column, that is the utilization factor, right? So that I can get the value from here. I can put it here slash QN. What is that QN? That is the quantity of material can be stored per meter square. It depend upon like the cement bags are there or free cement is there. Right? Depend upon the tiles are there. So that depend upon the QN. So QN you can calculate from the see the fifth column from the front beside the average stock day. So that I can calculate. I can take the value from here and just I'm putting into the value. I'm getting how much the storage area is required. Just we will take a small example. We will able to understand it. I think there is a slight format problem. Just a bit.